All right, today we're back where we were talking about the other day. We're adding and subtracting mixed numbers this time. Okay. A couple of different things we'll have to cover, but the same rules apply here that applied yesterday or Tuesday. Okay. Must have common denominators. Okay. So step one is must have common denominators on all fractions. Okay. Second thing that we will talk about is borrowing when subtracting fractions. Okay. Actually, subtracting mixed numbers. All right. Now, there is a misinformation out there that a lot of people say that when you have mixed number and you're adding or subtracting, you need to change them to improper fractions. That is not true. In fact, I'd encourage you not to do that. When you do that, you're going to be dealing with a lot larger numbers where careless mistakes are more easily made. And so therefore, I would encourage you not to change them to improper fractions to add or subtract. Now, eventually we'll get to multiplying and dividing. There we do have to do that, and that's a whole other deal. But for today, we're talking about adding and subtracting mixed numbers. So, for example, if we had this, 3 2/3 minus 1 1/3. Okay? First thing that we talked about is that they've got to have common denominators. Both the fractions have 3 as their denominator, so therefore we don't have to do that step. I already have common denominators. Once again, I would highly suggest that you put these vertically. Okay? You'll see in a minute when we start talking about borrowing how it can help you keep things organized more so than if you do them horizontally. If you want to do them horizontally and that's the way you like to do them, that's your decision. Okay? I try to do them vertically because it helps me in the long run. All right, now, so what I want to do is I want to take 2 and subtract 1 from it. Can I take 2 minus 1? Okay. 2 minus 1 would be what? 1. So that would be 1/3. Once again, once the denominator is the same, you don't subtract or add the denominator. You only subtract or add the numerators. Only add or subtract the numerator of the fraction. Now, obviously, we still have to take 3 minus 1, which is 2. So the answer to that is 2 1/3. You must simplify the fraction if possible. Remembering that the word simplify means simplest form or lowest terms. Okay, that was a fairly easy example because it already had common denominators. All right, let's look at another one. Let's see here. There we go. 6 4/7 plus 5 5/7. Once again, denominators are already the same, so I don't have to do anything with those. I simply have to take 4 plus 5. 4 plus 5 is what? 9. Put that over 7. 6 plus 5 is 11. Now, here's where some people start making more mistakes. Okay? Shouldn't, but we do. All right? As we look at this one, 9 over 7 is an improper fraction. That improper fraction we must change to a mixed number. So that means 7 into 9. 7 goes into 9 one time, be 7, remainder 2. Place the 2 over the 7. So it is 1 2/7 as a mixed number. Now I must take this and add it to 11. So I have 11 plus 1 2/7, which simply means 12 2/7. And 12 2/7 is your answer. Okay? Now, I'm going to give you one that has a common denominator already for it. Okay? I want you to do this one on your own. 8 7 over 12 plus 4 5 over 12. Do that one on your own. I'll give you about a minute. All right. Tristan, do you have an answer? What'd you get? 13. That is correct. Now, the way we get 13, simply add up 7 plus 5. That's equal to 12 over 12. Then we have 8 plus 4, which is 12. Okay. This right here is equal to 1. 12 over 12 is equal to 1. So I must add 1 to 12, which makes 13. Excuse me. Rephrase that. 12 plus 1, which is equal to the 13. Okay, any questions over that? Brandon, did you get that? What'd you get? You didn't add the 1? Huh? No, you asked me if it needed to be reduced, do I reduce? And I said, read the notes. You must reduce if possible. I did reduce the fraction. 12 over 12 reduces to 1. What did you reduce it to? 2? How did you get 2? Well, so you get 6 over 6. What's 6 over 6? 1. Or you could reduce it by 6 again, and it would be 1 over 1, which is 1. Okay? All right. That's why I gave you that one, because I knew it would be a little bit more different for you. All right. Now, let's look at fractions that don't have common denominators. For example, 4 3/4 plus 6 2/3. Okay? So I have to find a common denominator for 4 and 3. Okay? Well, in this particular case, I can simply take 4 times 3, which is equal to 12. And that is a common denominator, and it happens to be the least common denominator. So I'm going to change these fractions to have 12 on the bottom of them. This is one of the reasons I like doing them vertically, because I can stack the fractions on top of each other, and I can say, okay, what did I do to 4 to to make it 12? Multiplied by 3. So I do the same thing the top, which makes that 9. What did I do to 3 to make it 12? Multiplied it by 4, which gives me 8. So now I take and I go ahead and add 9 plus 8, which is 17 over 12, and 4 plus 6, which is 10. But once again, 17 over 12 is an improper fraction. So I divide 12 into 17. 12 goes into 17 one time, be 12, remainder 5. Take that 5 and put it over the 12. So now I have 1 and 5/12 that I must add to 10. So I have 10 plus 1 and 5/12, which is 11 and 5/12. And that would be your answer, with denominators that are not the same. Okay, so I want you to try this one on your own. Another addition, 5 1/4 plus 2 and 5/6. You have to first of all find the common denominator. So you're going to have a common denominator over here to the right. You have to figure out what that is. You can use a common denominator or you can use the least common denominator. There is a difference between the two sometimes. Not always, but sometimes there is. In this problem, there is a difference between a common denominator and the least common denominator. All right, let's look at it. First of all, our common denominator would be what, Jesse?
Our common denominator, 12.
12. How did you come up with 12, Jesse?
4 goes into 12, 3 times, 6 goes into 12.
Okay, that's fine. Count by sixes. Know that 6 and 4 both go into 12. What you may do here is if you took 6 times 4, that would be 24. That would be a common denominator, but it wouldn't be the least common denominator. When you don't use the least common denominator, you have to reduce more in your final answer. Okay, that's the only difference. Sometimes you also have to deal with a lot larger numbers. Okay, but here we can use 12. So, Jesse, you said we did what to 4 to make it 12? Multiplied it by 3. So we do the same thing at the top. Okay, a lot of times people will make a careless mistake here, and instead of going 3 times 1, they'll go 3 plus 1 and get 4, and that's obviously a careless mistake. Okay, 6 times what equals 12? 2. So I got to multiply by 2 to the top. So that gives me 13 over 12, And that gives me 5 plus 2, which is 7. Once again, I've got to change this from an improper fraction to a mixed number. 12 goes into 13 one time, be 12, remainder 1. Take that 1, put it over the 12. So that's 1 and 1/12 that I must add back to 7. So I have 7 plus 1 and 1/12, and that is equal to 8 and 1/12. And that is your answer. Gabby?
So, LCD is like the lowest common number, so that, for example, that one's 12.
Yeah.
And what's the other one called?
The other one's just a common denominator. Yeah. And either one will work, right, Jacob?
So, on our homework, will we have any common ones?
Well, what you use is up to you. Okay? Like, for example, you two done? Y'all done? Done? Okay. Just want to make sure that, because I don't want you to miss anything. For example, if I had a 6 and a 9 on the bottom, if you used the common denominator, what most people would do there would be 6 times 9, which would be 54, and they would use that as their common denominator. But what they should use is 18, because that's the least common denominator. Because when you use 54, then you're going to be multiplying by bigger numbers, and you're going to end up with a lot larger problem that's going to have to be reduced in the end. That's why I suggest using, it's always best to use the least common denominator. But a lot of times you can't, just right off the bat, maybe you don't see it, and so you just end up multiplying the two together. Christina?
When you, use other number, but it's the factor of both of them, but it's not the least common factor, you will end up reducing it more?
Yeah, like for example, let's just look at this one. Let's say that let's say we had 5 and 1/4 plus 2 and 5/6, and we used 24 as the common denominator, 6 times 4. Okay, if we did that, then you would have 6 here on top, and you'd have 20 on top of the other fraction. Okay, now you would take 20 plus 6, which is 26 over 24, and that would still be your 7. Here we would have, that would have to go from 24 divided into 26, goes one time, be 24, remainder 2. Take that 2, put it over the 24. So now I have 1 and 2 24ths, okay, but I've got to add it back to that. So that gives me 7 plus 1 and 2 24ths, which is 8 and 2 24ths, but now you have to reduce the 2 24ths. I have to reduce it by 2 over 2. 2 goes into that one time, 2 goes into that 12 times, so 8 and 1/12. You still get the same answer, there's just an extra step. Right, Tristan? Okay. Do we need to launch something towards your way? Okay. Then I really don't want to see the back of your head again. Okay. So that's adding. Okay. Let's look at the subtracting. This one's a little bit more difficult because you have to borrow. So I want to look at the borrowing aspect. Okay, for example, let's see here. Let me get one. Five and 1/4 minus 3 and 3/4. Okay, do they have common denominators? Yes, they do. So I move to the next step, which is to subtract. Can I do 1 minus 3? No. I can't do that. So I have to borrow. I have to borrow from the 5, making the 5 a 4. Now, I borrowed 1. Okay? I borrowed 1, so a fraction That would be 1, correct? 1 over 1? Okay. But can I add a 1 to a 4 on the bottom? No. I have to have common denominators. So that would be 4 over 4. Is 4 over 4 equal to 1? Yes. So I'm going to add 4 to 1, which makes it 5, and the 4 stays at the bottom. Stays the same. Okay? Now I can take and I can subtract 5 minus 3. 5 minus 3 is 2 over 4. 4 minus 3 is 1. 2/4 can reduce by 2 over 2. And that is 1 1/2, which is your answer. You always have to reduce if it can reduce. You will not always have to reduce, no. Enough. Gabby?
When you borrow, you have to make, like, when you get going with the 5,
Yep.
for example, it's like 1 over 6, then you're going to have to do 6 over 6.
Correct. Yeah. If I'm having to borrow from 5 1/9, and I borrow making that a 4, then I'm going to add 9 over 9. If I had 5 7/12 and I had to borrow, that would be a 4, and I would add 12 over 12. All you're basically doing is adding the denominator to the top part of the fraction. That's all you're doing. You don't even have to express it as 12 over 12, 9 over 9. You're just basically taking whatever the denominator is and adding it to the fraction, to the numerator. Okay? So let me do another one here. 9 1/3. Do you need to stand up? Well, you can stretch on your own time. 9 1/3 minus 7 4/9. Okay? Before we ever borrow, you must have common denominators. Common denominator between these two fractions is 9. So what did we do to 3 to make it 9? We multiplied by 3. So we do the same thing the top, which makes that 3 over 9. What do we do to 9? We multiplied by 1. We do the same thing at top, which makes that 4. Can I take 3 minus 4? No. So I have to borrow. I borrow from that, making it 8, and that makes this 9 over 9, which makes that 12 over 9. Now I can take 12 minus 4. 12 minus 4 is what? 8 over 9. 8 minus 7, 1. 8/9 it can't be reduced, so therefore 1 8/9 is my answer. Isaiah? Do what now? Where I got the red mark? Right here? I just borrowed. This is where I borrowed. I borrowed 1 whole. How did I get 12? I added 9 and 3 together and got 12. I'm basically just taking the denominator 9 and adding it to 3 when I borrowed. This is the borrow right here. That's what I borrowed, is the 9 over 9. And then I added 3 plus 9, which is the 12. Okay, and then I put it over the same denominator my same common denominator that I started with. Okay? All right, now, your homework. Your homework, we're going to start out, we're going to cut this into 2 different days. So we've got 5.2 and we're going to do 2 through 9. Need to make sure you have that done because it's going to be worth double points. Okay? We'll do the rest of it tomorrow. But I want to make sure that you've got this first part down before I give you a bunch of them. Okay, so 5.2, 2 through 9. Actually, let's go 2 through 10. Okay, 2 through 10.